you're supposed to find the domain of a function, that means you're supposed to write down all the values you can put into the function. In other words, you're supposed to find out all the numbers for x that work, all the values that don't break any math rules. So with a square root, the big thing we want to look out for is trying to square root a negative number, right? Because a square root means you're trying to find a number that multiplies to itself to equal -4. And you can't do that without imaginary numbers, okay? No number times itself equals -4 without imaginary numbers. So we want to look at this function, make sure we don't have negative numbers. So just try and plug in some values. So if you plug in -2 for x, this is going to give you the square root of -8, which, -8 times -2 is 16, 16 plus 8, that gives you 24. Negative times negative makes a positive there. That's okay. That's good. We're not taking the square root of a negative number. So let's try plugging in like 0 for u, and if you do that, sorry, not 0 for u, 0 for x. If you plug in 0, you're going to get out the square root of 8. That's fine. It's not like the cleanest number, but at least it's not negative. If you plug in +1 for u, and again, I'm just pulling numbers out of the air. You can try any number you want just to get to kind of know the domain of the function here. If you plug in +1, you get out the square root of 0, which is 0, and that's fine too. But what we can't have is a number like 2 or 3 or 4, because once you start getting further up in the positive numbers, okay, -8 times 2 gives you -16. -16 plus 8 gives you the square root of -8, which we just said we can't have in a function unless we're dealing with imaginary numbers. So this is not a real number, so we can't have 2 in our domain. So what we found is all the negative numbers are going to work fine. So this, in our interval notation, we start writing our interval using the smallest possible number. So I wrote -∞, because you can go as far back as you want in the negatives. And then I'm going to write +1 in a bracket, because I found the biggest number I could plug in was 1. Okay? 1 worked. It gave us 0. That's fine. But if you try to do like 1.1 or anything slightly bigger than 1, it's not going to work. Another way to do this type of problem, go to desmos.com/calculator, okay? And then don't worry about the u of x part. Just plug in the right side of the function. Type in sqrt for square root, and it graphs the function for you. Okay, and the domain is all the possible x values. So you can see we have -10 is a possible value because it matches up with the graph. You've got -25. It goes infinitely back in the negatives, so -infinity. That verifies what we just found. But the biggest x value we get is at 1. We can't have 1.1, can't have 2, can't have 3. The graph doesn't cross any of those x coordinates. So -infinity is as small as we can go. 1 is as big as we can go. So this is our domain. That's just another way of doing the same type of problem. Okay? You can do it entirely graphically if you want. All right, let's check out another one. Same type of thing with this one. You could do it. Let's just do this one with the graphical method. You could try plugging in some numbers to get an idea. But the square root of 18 plus 6x. Here's the graph of the function. So an interval notation expresses an interval from smallest to largest. So the smallest x value we have, we can't have -15 because the line doesn't cross there. It doesn't cross at x equals -10. The smallest x value is -3. And again, we need a bracket there because exactly -3 is okay. If you plug in -3 here, that's 18 plus -18, which is 0. And the square root of 0 is okay. So we have to use a bracket to show you can have exactly that number. And then, so that's the smallest, and the graph keeps going. The largest number we never reach is +infinity. And we always use a parentheses because you never reach infinity. Whoops, what am I doing? I have two computers in front of me, my desktop, and I'm typing this on my laptop. So, why is it? Oh, there's +infinity. Whoops, I got two infinities in there. Okay, so let me know if you want me to do a different problem.